We're still on dilations, and now we have example number 3. Now as you can see, it's the same example as what we have in the previous discussions. And today I'm going to tell you or teach you how to solve these graphical illustrations and be able to identify what kind of transformation this is. Is this a dilation or is this a translation? Does it have a vertical or a horizontal dilation, or a vertical or a horizontal did I say translation? Dilation. Okay. Now, as you see in the graph, we have two seemingly like common graphs here. And you can see the original function f. So we have the function f here, represented by these dotted lines with some points, specific points given. And we have the image function, which is represented by this solid line graph. Okay, and as you can see, these two graphs are illustrated in a 10 by 10 window of the grapher. So what we're going to do here is to actually solve the problem. The first one is to look at the transformation, and then the second one is be able to identify what kind of transformation was being done here. So as you can see, this is like a dilation, and obviously this is a vertical dilation. Now to look at at our premise, okay, we're going to consider the points in which this function graphs or these graphs were being illustrated at. So we have this first point here. Our point 1 is that's equal to 3 or negative 3 and 1. That's for this function, the lower function, okay, or the pre-image function f. Now look at this, another point here. It's 1 and 3. Okay, the pair of coordinates is 1 and 3. Now we have the other one here, and it's on, that's 4 and negative 2. Okay, this is 4 and negative 2. Now we look at the other transformation or the other graph. Let's look at the other graph. Our other graph here has points. This is the first one. We have 3 or negative 3 and 3. So we have negative 3 and 3. And for the next one, which is above, that would be 2. I'm sorry, that's 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 and 9. And the last one, we have here, after the stretch, we have here, it's 4 and negative 6. It's 4 and negative 6. Now let's investigate if there is any translation. Now you cannot see any movement in the x-axis. Okay, as you can see, these things here, or these x coordinates here, they are still the same, right? Now for the second part, as you can see, this is 1 and it became 3. This is 3 and it became 9. This is negative 2 and it became negative 6. Meaning that they are multiplied by a factor of 3. So it's times 3. Therefore, we could say that this graphical illustration here is a vertical stretch or a vertical dilation. And therefore, since they are multiplied by 3, if our original function is f of x, then our g of x, this is our g of x, and this is our f of x. So our g of x then would have a vertical dilation, which is multiplied by a factor of 3 for f of x, then it will look something like this. So our final answer would be g of x is equal to 3 f of x, which gives us our answer, which is a vertical dilation by a factor of 3.